Hello, am I audible?
Yes, sir.
Okay, so I am starting the lecture number 10 in continuation of 9, and this is again unit number 2 of the software engineering. So this is the system requirements specification. The abbreviation for this we use SRS. SRS means system requirements specification. So what could be the specifications? Now, for example, we can see here, your requirements document is the biggest I have ever seen. So requirements means what we are going to implement for any organization, then the particular organization or the institute is going to provide the written documents to you. Okay, then with the help of those documents, you can start your design. First, you will study all those documents which we are going to implement, then we can start the work. In another diagram you can see here, it's too big to read. Okay, then it is very difficult to read or go through all such type of documents. But I can guess from its weight what must be in there. Okay, so just I think it is very easy to know about the requirements of the any organization if we will discuss verbally, okay, or in the form of the meeting. Then just a few points we can note those points in the meeting, and we can form any team. Then it is very easy to handle. Okay, so instead of getting the documents, uh, we can say in so much weight, then it is better to collect some instructions or the guidelines or the requirement is a specification from that company or the organization. Now in the third one, you can see here, it's a multi-user global system, right? No, I am not getting that. Okay, but the person who have this weighty documents, then he will never get you. Okay, and he will never accept your invitation that you want to know something verbally, or you want to collect information, uh, verbal information. So the second one is the here modeling. So during the software requirement specification, we will do some type of modeling and we will use. Then in this case, we will check what are the benefits of building a model. Okay, so at the initial stage, we will design a model, and as per the design of the model, we will start our work. What needs to be modeled? Here we will check the different stages or points that by using those models, then what are the different needs for that particular model? System modeling, how we will do, then what is the requirement for the modeling? Here we can see function and information flow model. Okay, whenever we will develop any software or we will design any software, then software, it is nothing but the combination of number of functions. Okay, so it contains lot of information. Then we can use those function and information. We will design a flow model. So first we will prepare a flow model, and a flow model, it contains a number of functions and the concerning information. So what we will do with the data? So flow model, it contains, the function, and information means the data. Okay. So functions, these are the procedures, or we can say here we can also call the procedure to the functions, okay, or we can say the number of components. So we will divide our software into number of functions or the number of components. Data model is structure of the information. So data model, it is, as the name indicates here, is structure of the information, how we are going to store the information and how we will retrieve the information. For that, we will use the data model. Another is called the behavior model, how we interact with the system. So there are several components, okay, because at the initial stage, we will divide the software into number of components and we will use the model that is called the behavior model, and with the help of the behavior model how we are going to interact with the system, okay, because at the end there is a need arise to connect all those components or we can say the several data models or the behavior model. Now in this diagram, this is called the functional and the information flow modeling. Here you can see these are also called the DFD. Abbreviation is the DFD, data flow diagrams. So in the data flow diagrams, you can see here, first we have the source code as a input, okay? And this source code will approach to the compiler in the form of number of characters. So number of characters, we can also call these as the tokens. Okay, so source code will be divided into number of tokens, and then these number of tokens will go toward the compiler as an input, and after that we will get the machine instructions. Okay, and these machine instructions will form the object code. Ultimately, we will get the output here. Okay, whatever we need or the user need, then accordingly, as per the program specification, we will get here the output. Now from the compiler diagram, you can also see, because it also debug your program here, the compiler also here indicates about the error messages. Okay, so it gives two information, converts high level language into the low level language, that is the machine language, and also it indicates the error messages. Now in this case, we can again see here, just you come characters, the characters again, here we are going with we are doing here the syntax analysis, and then we will get the tokens, and then token will proceed toward the semantic analysis, and then again after the semantic analysis, the procedure will proceed towards the object code. Okay. So here we can see after the syntax and semantic analysis, these are the other phases of the compiler we have already studied in the fifth semester, different phases of the compiler. So ultimately at the end we will get the output. So here you can see DFDs also require a data dictionary. Okay, DFD, data flow diagrams, they also need a data dictionary in which we are going to store the data related to your source code or the source program, or for which you are going to design the software. Okay, and as per need, we can also retrieve the data from there. Now, data modeling, here we need data objects, attributes, relationships. Okay, and under this, we can see formatted as list or tables. So data objects and attributes, here the relationships. So with the help of the data modeling, we have three things. Just you can see here, we have the objects, attributes, and relationships. And these, during the data modeling, here you can see these things can be formatted as the list or the tables. So we can manage in the form of the list or tables. So table, it is nothing but a data structure. We can see data structure or the information or the data related to the your source code or the program. Okay, so in tables we can store all type of data. Entity relationship diagram. Now here you can see there is a security system and sensors, how we are creating the relationship between these two. So security system, this is have the connectivity with the sensors in the form of the monitors, and now the direct connectivity. Now here you can see enables or disables. Okay, we can enable or disable the sensors with without this have the interface with the security system. And here you can see the input or output is here is the programs. Okay, so entity relationship diagram can create any relation between the monitors here, security system and the sensor in the form of the monitors, or we can do the enabling or disabling here, and different tests we can use between these two entities here, security system and the sensor, and as an input or output we can use the here program. So this is the ER diagram we can draw for any system or the for the any database. It is just for the example. Now, what is the behavior modeling? In the behavior modeling, we will draw the transition diagram. Okay, and in the transition diagram, we will use different number of states. Here you can see this is the different states in the circle form 1, 2, 3. So these are the different states here, and how we are going to move from one state to two or two to three, or here it has no connectivity with the 2 and 3, but one state has the interface with the state number 4. Okay, and it will depend on the situation, what type of output you want to get, and accordingly you can draw the transition diagram. Why is it called the transition diagram? Because it is changing state from 1 to 2, 2 to 3, or as per need or requirement, okay, for which we are going to draw the transition diagram. So this is the starting state. Okay, so you start from here. So this is the initial state, state number 1. Now the read message. Okay, from here, just reading message, and it is going to stage 2. If here we are going to complete this, then it will send the information to this done. It is completed. Again, it will read the next line, next word. Okay, and after this, again will complete. So this is the transition diagram between 1 and 2. Okay, suppose just we want to read any message. Okay, and want to indicate this on the screen. Then 1 and 2, this is enough. Okay, only we can draw the state diagram here. So this is called the behavior model. What type of behavior the data is indicating here, or our program is indicating. Again, we will proceed or change the here state or transit the state here. Now you can see save message. Okay, after reading this message, then it here we are going to complete this. Again, suppose we want to save message, then we need new state here, and now we can indicate this as a 3. So this is here it will come, the output will come here, and here we can save this message. Okay, and now just to save the message, we are going to create the new file. Okay, so we will give or create a new file here. Again, we will return here maybe more messages, then it will go to this state, and again here we will do the nomenclature for the file, or we can store the same other message to this file name, and we can update this. So again we are coming to this, so then it is enough. So it is reading the message, it is okay, complete. You will get the output. Again, if we want to save into a file, then here we are going to save this message in a file. Okay, then it is okay. Now here you can see the new state from 1 to 4. it has the interaction or interface with this. Here you can see compose. Okay, just we are going to compose the message and it is sending to this. So compose and send, compose and send. So we can use here only 1 and 4. Okay. But if we want to read and complete, then we can use 1 and 2. Or we want to save message and create a new file, then we can use 1, 2, 3. And we want to do more work, then we can use this state also. So it will depend on the situation. Okay. For what we are going to draw the diagram. Okay. State transition diagram. So we can use different number of states as per requirement. Okay, then this is called the transition diagram because it is changing the state from 1 to 2, 2 to 3 or 1 to 4 as per need or requirement of the user. So this is the initial state. Okay, so next we will also draw some diagrams in the next few slides or next class. Now, technically speaking, requirement specification. What is the requirement specification for the software? Requirement and means understanding between customer and supplier. Okay. Suppose at the end, your software will be supplied by some other person and the supplier will interact the customer. So requirement means understanding between the customer and the supplier. What will be the requirement? So the supplier must be aware by the customer need. Okay. Specification means what the software must do. Okay, this is your work. The programmer is going to develop any software, but beforehand, you must be aware by the specification of the particular software before designing or before doing the coding, etc. Okay, so and then this is called the specification. So requirement is different than the specification. Specification means what the software must do. Okay. Requirement means understanding between the customer and the supplier. Now here we can see requirements that are not in the SRS. What is the SRS? Software requirements specification. Okay. So this is the abbreviation. Everywhere we will use this abbreviation SRS. SRS means software requirements specification. Okay, so remember this term. We will use always here SRS. Now requirements that are not in the SRS, that is the cost. Okay, software requirement specification. We are not including these terminology. Okay, or such type of requirement in the SRS. So SRS have some different, specification requirements. But these three terms here you can see the cost. We are not including this term. Okay, whenever we are going to develop the software, so this term cost, delivery dates, acceptance procedures, the IEEE organization is not including these terms in the SRS. So the requirements for the SRS is different than these few terms. Okay. Then what are those terms? We are not including cost. We are not including delivery dates. We are not including acceptance procedures. Okay. So requirement is different than the specification. Requirement is between the customer and supplier. Specification means for what you are going to develop the software. So you will always design or develop the software as per need or the requirement of the organization. Okay. So this is just the difference between the requirement and the specification. Now these are the different uses of the SRS. What are the uses? First is called the design, validation, customer contract. So we use this term rarely. Okay, not often, but we use rarely customer contract because this is we keep outside from the SRS. Okay. Now just we concentrate over the design and the validation. So for the design purpose, we use a number of different type of models whenever we are going to implement any software, and there are various models we can use out of them, anyone. Okay, then after each stage, we will validate. Why we are doing the validation? Because we want to keep in view the specification. After each stage, we will check the specification that are supplied by the organization. Okay, because at very early stage, we can check whether the software which we are going to design at each stage, it was validated or not. Okay, and at the end, we can also include sometimes customer contract. Now in the here in this diagram, you can read this. One of us will have to read this kinetic product requirements document. Okay, so again, the organization is providing you a very heavy or the very weighty or very thick documents, and you are the here people, so that you want to understand the different requirements of the organization, and it is now available in the form of the documents. Okay, so organization is providing you so that you can proceed your work or you can work accordingly. Unless it gets destroyed in a freak accident, okay, now you are thinking something else, that it is very difficult to handle such type of weighty documents. Okay, then you want only some sort of verbal discussion only, and you want noted down some few points related to the development of the software for which you are for the organization you are going to work. It's like watching Thomas Edison work. Okay, now you are saying that, oh, it is very heavy, bulky. It is very difficult to study or go through such type of instructions, and how we can implement the software as per the his organization requirement. I have some oily racks in my queue. Okay, so this is just you can see here. Here the it is showing sort of depression here, because he is inviting to get some sort of witty documents here. Now, what is the role of the SRS? This is developed. This was developed by the IEEE organization, and the nomenclature is as the IEEE 830. Okay, this is the standardization uh, for the SRS. So, what is the role of the SRS? Software requirement specification. So, the SRS must correctly define all of the software requirements. Okay, but no more. So, it includes the all requirements of the organization. Okay, this is the role of the SRS. The SRS should not describe design, verification, project management details, except for required design constraints. So SRS should not describe about the design. Okay, what type of model you will use, or how will you verify, or how will you manage the project, or what are the different details for that. Okay, so it is up to you, but there are few points which have to follow, now followed by the programmers or the designers, but it will not describe the design. Okay, means this will not give you the about different models. It will not describe about the different design models, or how will you verify those uh, components. Okay, or the details of the project management, but it gives you some design constraints. So there must be a inclusion of such type of conditions So it has. Okay. So only the SRS role is to aware by some design constraints. Now these are the different characteristics of the good SRS. Now, these are the points. There we can note unambiguous. Okay, your software must be unambiguous. That is designed by you. Unambiguous means error free, working properly, giving output as per the requirements or as per the specification. Means it is unambiguous. So it must be unambiguous if you are following the rules of the SRS. Okay. So for the good SRS, the characteristics must be unambiguous. Okay. Second is complete. It must be complete in all respect. Okay. Third one is the verifiable. You have already tested or checked at each stage. Okay. Verification must be completed. Consistent, modifiable, traceable, and usable during the operation and maintenance phase. It must be consistent, modifiable. You can modify up to before the finalization of the project. Okay, you can modify at each stage. Traceable, you can easily find out the different functions or the working of the functions, whether it is working properly. Usable during the operation and maintenance phase, so that you can use during the operation and suppose at the end during the maintenance phase. So it has all such type of characteristics. So these are the characteristics of a good SRS, means software requirement specification. So this is the specification, okay, for the software. Now desired SRS characteristics. Now main points just you are going to note down. These are the complete, consistent, changeable, traceable. Okay, so these are the very important points. These are called the desired SRS characteristics. Here you can see there are 7 characteristics of a good SRS, but now you can use here only these 4 characteristics, means these are mandatory: complete, consistent, changeable, traceable. Now ambiguousness. How will you check this ambiguousness? The control total is taken from the last record. Okay, ambiguousness, you can check your the last record of your project. The control total is taken from the last record. If you are going to choose anything, okay, any data from the last record, then it may be possible that it has the ambiguousness. The total is taken from the record at the end of the file. Suppose you have any one file and just you are going to choose the last record. Okay. The total, just suppose you are doing the total of some data, then from the hand file, you are going to choose the last record. So suppose this is one of the formula you are using for the total and you are choosing from the hand file. So it may be ambiguous. Okay. If you are just choosing from the last record, the total is taken from the latest record, or you are considering the latest record. Third, the total is taken from the previous record. So if you will choose the total from the previous record, so that you can validate, and then the chances of error may be less. Okay. Otherwise, if you will check at the end, so it may be possible the ambiguity. There may be ambiguity. So another example, all customers have the same control field. Suppose everybody is using the same control field, all customer have the same value in their control field. Okay, so this is the program which is developed by you, but used by number of users or the customer. then all customer have the same value in their control field. Now all control fields have the same format, okay, because you are developing the program, then all control fields have the same format. One control field is issued for all customers. So maybe possible the ambiguity, okay, ambiguousness, this is called that. So when a user fails to authenticate after a number of times, send a notification to IT. Now you can see here, sometimes user fails to authenticate, okay, because the number of users are using the same format or choosing the record from the same field, okay, and using all control field have the same format, all customer have the same value in their control field, or one control field is issued for all customers, then there must be ambiguity. So when a user fails, then we have to inform to the head of the IT, or we will give the notification to them. So clear and complete. Now you can differentiate what is unclear or what is clear. The system shall be able to read updates from MAD image, that is the medical images. Okay, the system shall be able to read updates. So we sometimes we use some type of softwares in the medical. Okay, then the system shall be able to read updates. Now the system here you can clear what is unclear. The system shall be able to import new tumor patient data supplied by. Just we are doing, this is the active data. Here we are using having the interface with the machine, and we are scanning the patient. Then how we will retrieve the data from there. Now you can see. So MAD image here, it is you are using any software, and we are getting some medical images. Okay, with the help of suppose uh, we are using the machine, MRI machine. Then how we will retrieve the data from the body here. You can see the system shall be able to import new tumor patient data supplied by MAD image to the radiology management system. Okay, for evaluating the tumor to be malignant or benign. So just we are going to differentiate what is this and this. Between evaluate, suppose we want to evaluate the tumor, or we want to study about the tumor of the patient there, and how we will get the data related to that. And on the behalf of the data, we can differentiate between the malignant or the benign. Okay, here we can differentiate. So this is clear. Okay, and if we have only this updates, then we cannot say, because the previous data we haven't in this case. So we can say it is unclear. Okay, the system shall be able to provide historical reports here. Now the system shall be able to provide patient tumor data for the past 5 calendar years. Okay, so here it is, this statement is not so much clear, but this is clear because the time is given past 5 calendar years, and we can then easily compare that data. Okay, so clear and complete. Suppose we are going to develop the software, and if it is following the SRS points, that is the what are the different characteristics, and it is following the characteristics of the SRS, then this is the different. It must be complete. So complete in on which behalf here we can see if the, this is the we are getting the data or retrieving the data that is time bound. Okay. Now expressing requirement through input and output specification, because this have the interface with the input and output devices, and we can use here a IEEE 830 format. This is the one of the standardization standard which we can use for the input output specification. Okay, so IEEE 830 format we will use. So this express the requirements. Use of representative examples, specification through models. Now first taking your attendance. Only 1 minute left. SRS table of contents here. So this is the table contents, introduction, purpose, scope, definition, preferences, general description, product perspective, product functions, user characteristics, general constraint, assumptions and dependencies, specific requirements. Okay, specific requirements. Under this, we will study functional requirements. What is the functional requirements? And after that, under the SRS, we will also study external interface requirement, performance requirement, design constraints, attributes, other requirements. Okay. So other specification techniques here, you can see use cases, formal specification languages. So this is the end, and here we will continue again the same SRS requirement, and we will discuss next function requirements as well as the external interface requirements, performance requirements, design constraints, etc. Okay, in the next class. Thank you. If any query, you can ask.